Okay, hi everybody. I wanted to show you a couple examples of centripetal force problems and circular motion problems. And so what I've done is I've organized three problems here that are roughly increasing in difficulty. Okay, so the first problem asks, right here, what is the angular frequency of an hour hand? Now, you have to think this through a little bit. The angular frequency of an hour hand, that's the radians per second for an hour hand. You can't figure this out unless you can get the period first. So you figure out that the period of an hour hand is 12 hours, because it takes 12 hours to go from 12 back to the 12 again. Now, none of this works unless you have frequency in terms of seconds, and that way, period in terms of seconds, and that way frequency can be cycles per second, and angular frequency can be radians per second. So the frequency, so let's put the period in seconds, which is going to be 12, that's hours, times 3600, which is the number of seconds in each hour. And we can take our calculator and multiply that through. 12 times 3600, and that gives us 43,200. That's seconds. And then we use the formula here. The frequency is going to be 1 over that. So we use this formula. Omega is 2 pi f to give us the angular frequency. So here it is, omega is 2 pi f, which is 2 times pi times 1 over 43,200. And we need the calculator again to get that, I think. So we want the reciprocal of this 43,200 times 2 times pi. And we get an angular frequency of, that's 0.000145, or 1.45 times 10 to the negative 4 radians per second. 1.45 times 10 to the negative 4, which we can say e negative 4, and that's radians per second. Okay, so I feel like that one is kind of on the easy end. The next one says, what's the centripetal force required to keep a 50-gram ball on a string going around a circle of radius 65 centimeters 5 times in 3 seconds? What provides the centripetal force? So here, keep track of what you know and what you want. So what you know is that the mass of the moving ball is 50 grams, which is 0.05 kilograms. The radius of the circle is 65 centimeters, which is 0.65 meters. So you got to get used to using these units. And we've got to get the angular frequency. We know the period we know the frequency is going to be 5 times every 3 seconds. So that's going to be 5/3 cycles per second. And so the angular frequency should be 2 pi times that, and we want the centripetal force. So we're going to use the formula that gives us the relationship between force and angular speed. And that's the force equals m omega squared r, which in this case is going to be m, which is 0.05, times omega squared, which is 2 pi times 5/3, and all of that is squared, times 0.65. So we'll take our calculator. We'll take our calculator to figure that out. So we have a 0.05 times, and then open parentheses is going to be 2 times pi times 5 divided by 3, close parenthesis, squared. So that's omega squared now. And then we multiply that by 0.65. And we see that it's going to take a force of 3.56 newtons. which is like 350 grams weight. That doesn't seem too reasonable. So 3.56 newtons. Now, the centripetal force is caused by the force in the string, and that's tension. Okay, so finally, we come to a more difficult problem where we have a 1,200 kilogram automobile taking a quarter turn of radius 30 meters in 5 seconds. What's the minimum coefficient of static friction necessary to support this turn? Now, what we've asked about is the amount of static friction here. So what you know is the mass is 1,200 kilograms, and you know the radius is 30 meters. And yeah, the period here is going to be actually 20 seconds. So because it's a quarter turn in 5 seconds. So you know the frequency is going to be 1/20th of a second. Now, this is going to allow us to find the centripetal force, but the problem is I didn't ask you for centripetal force. What I asked for was the coefficient of static friction, but you can get that from the centripetal force. You have to recall the definition of the force of friction, and you have to recognize from reading this problem that it's static friction that causes the centripetal force. And that's what makes this problem difficult. But once you've understood that, it's really not very hard. So effectively, what I'm asking you to remember is that the force of friction is equal to mu, which is the coefficient of friction, times the normal force, which is the same thing as mu mg. So if you find the centripetal force, you can then set it equal to mu mg, and then you can find the minimum coefficient of static friction. And so we'll go through and work that. Now the rest of the problem is similar to the last one, so I'm just going to copy this and put in the different numbers, because sorry, wrong one. So this one, we know the mass is 1,200, so we'll put a 1,200 there. And it's 2 pi, but it's 2 pi times 1/20th. And then the radius of the circle is actually 30 meters. So we're going to get a much larger centripetal force, as you would expect, because it's a car spinning around a circle. So we take our calculator, and we have 1,200 times, open parentheses, 2 times pi divided by 20 in this case, close parentheses, and all of that becomes squared, and then we multiply that times 30, and we get an overall force of 3553, which I guess the three significant figures will say is 3550, so that's 3550 newtons. You can have the 3553 if you want, but we really don't know it that well. So that's the centripetal force, which is caused by the force of friction. So then we go back to this one, and the centripetal force we now know is 3553. And that's equal to mu mg. Mu is what we're trying to find, which is 1,200. G is 9.8. So we just use our calculator again, and that'll give us our value of mu, which should be equal to 1,200. Should be equal to 3553 divided by the product of 1,200 and 9.8, close parentheses, equals 0.302. We'll call it 0.30. So as long as the coefficient of static friction is 0.30 or more than that, then you should be able to make the turn. If it's less than that, then you won't be able to make the turn. One interesting thing about this is if you've gone straight from the equation here about centripetal forces m omega squared r and set that directly equal to mu mg, you actually don't even need the mass in this problem. This is an example of a problem where the masses cancel, but I wouldn't do that to you right now. So I hope this all helps.